Hello, dear students. I had already discussed the basic concept of hypothesis testing, the important terms used in hypothesis testing. Now, this lecture is all about the steps of hypothesis testing, how we test a hypothesis for accepting and rejecting the null hypothesis. Hypothesis testing refers to testing an assumption on the sample data which is drawn from a population with the objective to infer or estimate about the population. The methodology employed depends upon the nature of the data, which can be metric data or non-metric data, and it also depends on the objective of the study. So the researcher must be very clear about the research question and the objective of the study. So we can define hypothesis testing as a systematic way of inferring from a sample or population with the intent of making a determination about the expected behavior of the entire population. Now, these are the 7 steps that are employed in testing a hypothesis. Step 1 is to set null and alternate hypothesis. This is the very important step to frame your null and alternate hypothesis. For doing this, one must be very much clear about the objectives, what he wants to do in the research. Second step is to determine the appropriate statistical test. This is yet another important variable, uh, another important step in determining how we can accept and reject the null hypothesis. Third step is to set the level of significance. I will be discussing all these steps in the later slides. Set the decision rule, collect the sample data, analyze the data, and arrive at a statistical conclusion. All these steps are interrelated. Till step number 4. Step number 1, 2, 3, and 4. These steps are done before collecting the sample. That is, before we go in the field to collect the sample, all these 4 steps should be done beforehand. After going, after being into the field to collect the sample data, after that we analyze the data and come to a conclusion. All these steps are done after we collect the data. Now let us see these steps one by one. Now see, the first step is set null or alternate hypothesis. The first step is formulation of your hypothesis. As I discussed in my previous lecture also, the null hypothesis is the hypothesis which is tested for possible rejection under the assumption that it is true. It is denoted by H0. The null hypothesis theoretically is set as no difference or considered true until and unless it is proved wrong by the collected sample data. The null hypothesis is always expressed in the form of equation which makes a claim regarding the specific value of the population. In this, we had taken an example which says the population mean x bar is equal to the sample mean mu. Coming on to alternate hypothesis, it is a logical opposite of your null hypothesis. Whatever your null hypothesis says, the alternate hypothesis is the opposite of that. It is denoted by H1. In the example, we have said that H1 is such that the population mean x bar is not equal to mu. Step number 2, determine the appropriate statistical test. Test statistic measure how close the sample is to the null hypothesis. All test statistics follow a statistical distribution. Selection of appropriate statistical test depends on the type of data collected in the sample. If the data is metric data, very important, if the data is metric data, or when the scale is interval or ratio scale, then parametric tests are used. Parametric test, for example, z-test, t-test or f-test. And if the data is non-metric data, that is the scale is nominal or ordinal, then non-parametric test, that is chi-square test, for example, it is used. All these tests I will be discussing in my upcoming lecture. So type, number and level of data may provide a platform for deciding the statistical data or statistical test. Apart from these, the statistics used in the study, for example, mean, proportion, variance, etc., must also be considered when a researcher decides on appropriate statistical test. Now coming on to level of significance, it is very important. It is denoted by alpha, which is the probability of rejecting the null hypothesis when it is true. The variability. The purpose of testing of hypothesis is to infer about the population on the basis of a sample. The variability or variation existing in the population is categorized into two broad parts. Number one is chance variation and number two is cause variation. The level of significance denotes the leverage in the estimation of a population parameter such that it is having only chance variation with no cause variation. That is, the level of significance is a function of chance variation. We are taking a chance. This level of significance is taken due to the fact that the researcher can remove the impact of cause variation, but the researcher cannot remove the impact of chance variation. That is something happening by chance. We cannot cater for that. If something is happening because of cause, for example, these days coronavirus is a cause of lockdown, but sudden viral fever is by chance. You get viral fever by chance. Now, for another example, you will understand this more clearly. Consider a situation in which a production house is producing some defaulted products. On doing the research, the worker have found that it is the wrong products are produced because of the improper machine maintenance. We are getting improper products because the machine maintenance is not done since long time. We are getting a wrong product because of a cause, and the cause is improper maintenance of your machine. Okay, and if another example, if we are getting improper product because of the fatigue of the worker sometimes not happy, sometimes very tired, because of that we are getting improper products. It is by chance. The worker may not be tired every day, So it is by chance that today the worker is very tired, he is fatigued, he is absent mentally, so we are not getting the good product. This is by chance. So level of significance is considered as a chance variation which cannot be rectified. So we fix it to 5% or to 10% or to 1%. If the level of significance is 5%, then in that case the confidence level is 95%. Step number 4, to decide the decision rule. For making a decision regarding the acceptance region or rejection region, the researcher had to determine the critical value which separate the rejection region from the acceptance region. The determination of the critical value depends on the size of the rejection region, which is directly related to the risk involved in the decision making. Now step number 5, collect the sample data. We will go into the field to collect the sample. We will collect the sample data. We will fix our sample size. All the above 4 steps are done before collecting the data. And after the step number 5, all these steps are done after we collected the data. Now coming on to step number 6, analyze the data. The researcher has to compute the test statistics. This involves the selection of an appropriate probability distribution for a particular test. The test statistics and the level of significance are already being decided in step number 2 and 3. In this step, the researcher has to compute the test statistics and draw a statistical conclusion for the same. That means the researcher will either reject the null hypothesis or accept the null hypothesis. First, decide whether the test statistics falls in the acceptance region or in the rejection region. The region of acceptance refers to the range of values that leads the researcher to accept the null hypothesis. If you see this example, when the sample size is less than 30, the use of normal probability distribution z-test is not accurate choice. So, when the sample size is less than 30, we use t-distribution test or t-test. When the sample size is more than 30, we use z-test. Some commonly used test statistics are z-test, t-test, f-test or chi-square test. The last step, after we calculate the test statistics or we calculate the observed value, after that we arrive at a statistical conclusion. If the observed value falls in the acceptance region, we accept the null hypothesis. If the observed value lies in the rejection region, we reject the null hypothesis. This will be clear or I should say the 7 steps of hypothesis testing will be clear with this example. The example says you need to understand the question very carefully. A marketing research firm conducted a survey 10 years ago and found that the average household income of a particular geographic region is rupees 10,000. Mr. XYZ, who has recently joined the firm as a vice president, has expressed doubt about the accuracy of the data. For verifying the data, the firm has decided to take a random sample. Random sampling is used. A random sample of 200 households that yield a sample mean of rupees 11,000. Assume that the population standard deviation is equal to 1200. Now you need to verify Mr. XYZ's doubt using 7 steps of hypothesis testing. Here, if you see the question very carefully, here the sample size is equal to 200, standard deviation is equal to 1200, level of significance, that is alpha, is equal to 5% or 0.05. Now, as per the 7 steps of hypothesis testing, step number 1 is set null or alternate hypothesis. Here, the null hypothesis is such that the population mean is equal to 10,000. Alternate hypothesis says that the population mean is not equal to 10,000. If you see carefully the alternate hypothesis, it is a two-tailed test because the direction is not mentioned. The alternate hypothesis is saying that the population mean could be less than 10,000 or more than 10,000. The second step is to determine the appropriate statistical test. Since the sample size is 200, which is greater than 30, so we use Z statistics. Z formula is given, which says Z value or the observed Z value is equal to sample mean minus population mean divided by population standard deviation divided by sample size, under root of sample size. The significance level is is already mentioned in the question, which is equal to 5%, which is equal to 0.05. Step number 4 says set the decision rule. It is clear it is a two-tailed test from the alternate hypothesis. Level of significance is also mentioned. So the acceptance region is 95%. Critical Z value, which is obtained from the Z table for the acceptance region 95%, is always equal to plus minus 1.96. If the computed value or the observed value of Z lies in between plus minus 1.96, then we accept the null hypothesis, and if the computed value lies in the rejection region, then we reject the null hypothesis. The sample size is already mentioned in the question, which is equal to 200. Step number 6, analyze the data. We put all the values mentioned in the question into the Z formula, which I had already shown you in the previous slide. Sample size n is equal to 200. Population mean is equal to 1100. Standard deviation is equal to 1200. Sample mean is equal to 10,000. Put all these values in the Z formula, you will get 11.79. 11.79 is the observed value. If the as you can see, 11.79, which is the observed value, is greater than 1.96, it lies in the rejection region. This will be clear with the help of the graph which I have shown in the upcoming slide. And we come to the conclusion that the calculated Z value 11.79 is greater than plus 1.96. Hence, the statistical conclusion is to reject the null hypothesis and accept alternate hypothesis. The calculated Z value is also known as observed value. In this example, 11.79 is the observed value and 1 plus minus 1.96 is the critical value. Now this will be Now this graph shows the acceptance region and rejection region. I had also discussed this graph in the two-tailed test in my previous lecture. Now if we see this graph according to the example in this presentation, the observed z value, which is calculated by the help of z test, is equal to 11.79, which is greater than plus 1.96. So that value lies in the rejection region. So we had rejected the null hypothesis. Now I am explaining this graph again. The acceptance region is equal to 95%, which is equal to 0.95. As the level of significance is 5% in the question, therefore the acceptance region is 95% or 0.95. As it is a two-tailed test, so we had divided the significance level 0.05 by 2, which is equal to 0.025. So the area of this rejection region is equal to 0.025. If we add this value, we get 0.05. So this graph is a two-tailed test with z critical value, which is obtained from the z table, which is equal to plus minus 1.96. Clear? As in the example we got the observed z value, which is equal to 11.79, which is lying in the rejection region. That is why we had rejected the null hypothesis. I hope these 7 steps of hypothesis testing is clear to you, and the z-test, how to do the z-test is also clear. Z-test is always used when the sample size is greater than 30. Then only we use z-test. If the sample size is less than 30, then we use t-test. T-test and chi-square test I will be discussing in my next lecture. Thank you. Have a great day and be safe.